Hi everyone, I hope your week is going well. So Ms. Montes and I talked and we realized that students have been reaching out and letting us know that the video links that were attached to this week's assignment are not helpful. And I'm sorry that they're not helpful, but we understand. So what we decided to do is create this video to hopefully better explain how to do this week's assignment on solving rational equations, and hopefully it will help you complete the assignment. Before we start, I have to mention that this assignment was created long before Ms. Vito Montes even took over the classes. She is new to using Teams, and the whole online learning, everything's still new to her. I mean, it was all new to us. It's only, well, we're familiar with it because it's already been a month that we've been online, right? So I just ask for you to be understanding and for you to be patient. Our goal has always been to keep things easy for you and simple. So please just let us know if it isn't or if you need help because Ms. Vidomantis and I are just here for you, okay? We are here to help. All right, let's go ahead and start. This video is going to be a two-part. So the first part, I'm going to explain the key information that you need, um, the skills that you need to be able to do this week's assignment. And then the second part of the video, I'm going to go ahead and actually solve some of the problems that are on the assignment. Starting with number 1. So the topic for this week is solving rational equations. So in the end, you are going to be solving equations. Just something simple as 5x equals 10. You need to know how to do the inverse operation and just be able to solve for the variable. Okay, so just that. Multiplying variables. This is something that a lot of students still get confused with. When you're multiplying variables, so let's say x times x, you have to add the the exponents. So 1 plus 1 is 2, so x times x is x squared. Now, when you're adding variables, that's different. When you're adding variables, you add the coefficients. So 1x plus 1x is 2x. Here's another example. Let's go with 3x squared times 2x cubed. Since we are multiplying, let's go to multiply the coefficients. 3 times 2 is 6. And when you multiply the variables, you add the exponents. So 2 plus 3 is 5. You don't multiply the exponent, so it's not 6x to the 6th power, you add. Now, what happens if we were to add these two terms? 3x squared plus 2x cubed. When you're adding or subtracting, you can only combine like terms. And like terms are depending on the degree. So here, x squared and x cubed are not like terms when we're trying to add. So you cannot actually add these two. So there is no answer to that. Okay, so you need to know how to multiply variables. Next, fractions. What really matters with fractions are the denominators. Okay, it needs to be common denominator. When you add or subtract fractions, have to have common denominator. When you multiply fractions, you just multiply straight across. When you divide fractions, you multiply the reciprocal. So again, when you're adding and subtracting fractions, you have to have a common denominator. When you multiply fractions, you just multiply straight across. When you divide fractions, you multiply the reciprocal. And I will explain it again once we get there, but this is what you need to know. Factoring, SDB just stands for slide, divide, bottoms up, and difference of squares. You need to know how to factor GCF as well, actually. So I'm going to add this in, GCF. So you need to know how to recognize a GCF, a slight divide bottoms up, and difference of squares when factoring. So difference of squares is when you have a binomial but you're missing the b. And the first term can be square rooted and the second term can be square rooted. When you square x squared, you get x. When you square 4, you get 2. The only thing about difference of squares is that one of the factors have a positive sign and the other one has a minus sign. So here's another one. All right, we're missing the b, and the sign is always the subtraction sign. So difference of square, when you square x squared, it's just x. When you square 25, it's 5. One has a plus sign, one has a minus sign. One more. So if you notice, there's always a pattern, right? The minus, the subtraction signs, and you're missing the b. Ooh, this is squared. Square root of x squared is x. Square root of 100 is 10. One always has a plus sign, one always has a minus sign. Last thing you need to know is that when you're solving rational equations, you will either get one solution, two solutions, or no solutions. Those are the only possible answers that you can get. Here's a first example. The key to solving rational equations are the denominators. We want the denominators to be identical across the entire problem. So if you see here, we have 6k squared, 3k squared, and k. We need these three denominators to be the same. So what you're going to do is you're going to start just multiplying. Basically, you're going to multiply until you get a common denominator. I can already tell that to turn 3k squared into 6k squared, I just have to multiply by 2. Right? 3k squared times 2 will give me 6k squared, and they will match. When you multiply the denominator, you have to multiply the numerator. Okay, now what can I do to k so it matches with the other two denominators? What times k will give me 6k squared? K times 6k. Remember, when you're multiplying variables, you add the exponents. So exponent 1, when you add, it gives you 2. When you multiply denominator, you multiply the numerator. Let's just rewrite it out. One times 2 is 2. 3k squared times 2 is 6k squared. Minus, right? That sign doesn't change. 1 times 6k is 6k. K times 6k is 6k squared. When you have the same denominator across the entire equation, all you really have to focus on are the numerators. So what I'm going to do is just rewrite the whole thing, but only rewrite the numerator. And that's it. From here, you just have to solve for the variable. So I'm going to subtract 2. 1 minus 2 is negative 1. Bring down negative 6k. Divide negative 6. So k is equal to positive 1 over 6. Now, don't just assume that this is the correct answer. We have to double check our work because we might have an extraneous solution. Remember, extraneous solution are the false answers. They're the answers that end up being wrong. So I'm going to check my work by plugging this number back into the original problem. So our solution that we got so far was 1 over 6. And I'm just going to plug this back in. One over 6. We are going to be working with fractions. And I know you're not happy about that, but to be quite honest with you, we have to start working with them because you will need to know how fractions work as you advance further into the math courses. So let's go ahead and simplify. If you don't see a sign between terms, it just automatically multiplication. So it's 6 times. Now please follow PEMDAS. Exponents first, parentheses, exponents. 1 over 6 squared just means it multiplies itself like that. 3 times 1 over 6 squared just multiplies to itself, minus. Okay, now this looks very complicated, but it's not, don't worry. This is where we have to apply some of the fraction rules. So when you're multiplying fractions, you just multiply straight across. If you're not sure where the 6 goes, just turn that into a fraction. So 6 times 1 is 6, so 1 divided by 6. 1 times 6 is 36. 3 times 1 is 3. 1 times 6 is 36. Right? Now from here, what I'm going to do is simplify. 6 divided by 36 is actually 1 over 6. Same thing here. Oh, actually, let me fix this first. 3 divided by 36 is 1 over 12. Okay? Now, the next fraction rule that we have to apply is when we divide fractions. So if you notice, it's 1 divided by a fraction, 1 divided by a fraction, 1 divided by a fraction. When you divide by a fraction, that is equivalent to multiplying it to its reciprocal. So what that means is the numerator stays the same. So 1, instead of division, we're going to do multiplication. And you take the reciprocal of this fraction. Reciprocal just means flip the fraction over. Doesn't mean you change sign, you just flip the fraction over. So instead of 1 over 6, it becomes 6 over 1. But the sign stays the same. 1, so the numerator stays the same. Instead of dividing a fraction, we're going to multiply the reciprocal. Minus 1, numerator stays the same. Divided by a fraction. Instead, we're going to multiply the reciprocal. And now we just have to multiply. 6 divided by 1 is 6. 6 times 1 is 6 equals 2. 12 divided by 1 is 12. 12 times 1 is 12. 6 divided by 1 is 6. 6 times 1 is 6. And it's asking us to subtract. 6 equals 2. 12 minus 6, which is 6. And 6 equals 6, so that is correct. So this solution, k equals 1 over 6, that we solved for in the beginning, this is correct. This is the right solution. Okay, let's do another one. Again, the key is to have a common denominator across the entire problem. So we have x, we have 5x, and this one doesn't have a denominator. So what are you going to do? Just put it over 1. So we have these 3 denominators are just different, but we're going to multiply, find the lowest common multiple, and just figure out which one I can change and whatnot. So let's see. X, I can turn x into a 5x by multiplying it by 5. Again, what you do to the denominator, you have to do the same to the numerator. So then this will become 5x. This was already 5x. How about this one? can I somehow turn this 1 into a 5x so it matches with the other denominators? And the answer is yes. You just have to multiply by 5x. What you do, multiply in the denominator, the same in the numerator. And let me just clean this up. 5 times 1 is 5. 5 times x is 5x. This fraction stays the same. 1 times 5x. Oop, don't forget the plus sign or minus signs. 1 times 5x is 5x. 1 times 5x is 5x. Once you have the common denominators, you just have to focus on the numerators. 5 equals 6 plus 5x. And you're just going to solve for x. So subtract 6 here. That's negative 1. Divide by 5. So x is equal to negative 1 over 5. So this is a solution that we got. And again, just because you got it, it's not necessarily guaranteed that it's the right solution. So just to be safe, I am going to check my work. So we're going to check if negative 1 over 5 is the right solution. Let me plug it back into the original problem. Negative 1 over 5, negative 1 over 5. All right, let's see what I can clean up. This one, there's nothing I can do, so I'm just going to leave it. So for now. All right, now it's asking us to multiply. So when you multiply fractions, you just multiply straight across. So I'm just going to go ahead and put this one here. 5 times negative 1 is negative 5. 1 times positive 5 is positive 5. And I just bring down this 1. Okay, let's see, what else can I simplify? Okay, next fraction row. When you divide by a fraction, that is equivalent to multiplying it to its reciprocal. Reciprocal is when you just flip the fraction over, do not touch the sign. 6 divided by, well, negative 5 over 5. Negative 5 divided by 5 is negative 1. So 6 divided by negative 1 is just negative 6. And I'm going to bring the 1 down. 1 times negative 5 divided by 1 is negative 5. Negative 5 times 1 is negative 5. Negative 6 plus 1 is negative 5. So negative 5 does equal negative 5. Meaning this solution that we got is correct. I hope it's getting a little bit easier. But if not, just keep watching. I have more problems. Okay, now look at this example. This one looks a little bit more complicated, but it's really not. Again, you just have to put your focus on having the common denominators. So I have 4b squared, 2b squared, and 2b squared. So what can I do so that they all become the same? To me, it's a little bit obvious. If I multiply 2b squared times 2, I get 4b squared, which I already have. So I'm going to do that. 2, what you multiply in the denominator, make sure you multiply in the numerator. So I'm good with this one. Let's check this fraction. 2b squared. Well, 2b squared times 2 will give me 4b squared. And I know this is 4b squared and this is 4b squared. So I'm going to have the same denominators, which is perfect. What you multiply in the denominator, the same in the numerator. And I'm just going to rewrite this. Nothing happens to the first fraction. Plus sign. 3 times 2 is 6. 2b squared times 2 is 4b squared. Equals. Here, this is saying that 2 multiplies to everything in the numerator. So it has to multiply the b and has to multiply the 4. So please be careful. 2 times b is 2b. 2 times 4 is positive 8. 2b squared times 2 is 4b squared. As soon as you have common denominators across the problem, you just have to focus on the numerators only. So b plus 6 equals 2b plus 8. Combine like terms, b plus 12 equals 2b plus 8. I'm going to subtract this variable to the left. 1b minus 2b is negative 1b. Subtract this 12 over to the right side. 8 minus 12 is negative 4. Divide by negative 1 to get rid of the negative sign. And b is equal to positive 4. So again, that is the solution that we got, but I am going to double check just to make sure. So I take that number and I just plug it back into the original problem. So we have b equals 4. So what I do is I just rewrite the problem, but I just leave all the variables blank and I replace them with parentheses, just so I know when I go back where the values get plugged into. It's just easier that way. So I know I'm not missing anything. And look, I just missed it. Okay, and the number was 4. And let me go ahead and solve. 4 plus 6 is 10. 4 squared is 16. Again, this is multiplication. If you don't see any sign, it's always multiplication. 4 squared is 16. 4 times 4 is 16. 16 times 4 64 plus 3. 4 squared is 16. 16 times 2 is 32 equals 4 plus 4 is 8. 4 squared is 16. 16 times 2 is 32. Okay, but if you notice, my denominators are not the same. The first method is to simplify this fraction, 10 over 64. They have 2 in common, so if I divide by 2, I can get 64 to match the 32. The other way is to switch the 32 to match to 64 by multiplying it by 2. It doesn't matter which method you choose, you're going to get the same answer regardless. So it's just a matter of, what do you prefer? Do you prefer to divide or do you prefer to multiply? I'm going to go ahead and divide because I just have to divide once instead of having to multiply twice. So, divide by 2, divide by 2. There you go. When you have common denominators, you just focus on a numerator. 5 plus 3 equals 8. 5 plus 3 is 8. 8 equals 8. That is correct. So that means this solution, b equals 4, is the right solution to this problem. So I guess the main thing you have to be good at is just getting the common denominators. Okay, I have one more example for this part of the video. N cubed plus 5n squared. All right. And then I have n plus 5. And then I have n squared. Please understand that in math, there's multiple ways of doing the exact same thing. It's just preference. So one of the ways that you can go about this problem is by factoring. So when I look at this denominator, I can tell that this term and this term have something in common. So if they have something in common, I'm able to factor that out. So what that looks like is I have 3 n's here and I have 2 n's here. So I can take 2 n's from both terms. And I'm left with n plus 5. Right? So what that does, it shows me that the n plus 5 was shared between these two fractions, and n squared was common between the first one and the third fraction. So what does that mean? We want all of them to have the same thing. That's how you get common denominators. So if I have n squared here, and I have n plus 5 here, but I only have n plus 5 here, well, I want the n squared here as well so that it matches. So that I can multiply this by n squared and the top by n squared. And look at the third fraction. I have n squared. Okay? This one has n squared, this one has n squared, perfect. But the first fraction has n plus 5. The second fraction also has n plus 5. So if I want them to be the same, then this also needs to have n plus 5. And make sure you multiply both numerator and denominator. Right? So that just helps me see what the denominators need to have. Let me clean this up. Four times n squared is 4n squared. N plus 5 times n squared. 1 times n plus 5 is just n plus 5. N squared times n plus 5. I know a lot of you guys are wondering, Miss Choi, why aren't you distributing the denominators? You can, but remember that the moment you have common denominators across the entire problem, you don't need them anymore. You just need the numerators. So if I only rewrite the numerators down, 5 equals 4n squared plus n plus 5. And all I have to do is start solving it. Subtract this 5 over. When you have one of the sides of the equation completely blank, you actually can't leave it as blank. You always need to have something on either side. So if it's blank, just fill it up with the number 0. Okay, so now we're here. And you're probably wondering, Miss Choi, what do I do next? You still have to continue to solve for n, whatever the variable may be. Okay, but how? Remember, there's so many different things that you can do. Always take a look and see if you can factor them out. And you can. I have 2 n's here, I have 1 n here, so I can actually take out 1 n. And that will leave me with 4n plus 1. If you're not sure, just work backwards. N times 4n is 4n squared. N times 1 is n. Okay, so now here, after you've factored everything out, there's nothing else that you can do. But I still have 2 variables, which doesn't make sense. What you're going to do when you get to a point like this, when you have multiple variables but there's nothing else you can do, you're actually going to just separate them and set them all equal to 0. So here, this means n times 4n plus 1. So the n is going to get separated from 4n plus 1. And we're going to set each of them equal to 0 and just solve for n separately. So okay, so n equals 0. So that one's already solved for. So I'm going to leave it alone. But this one, n is equal to negative 1 over 4. So we have 2 solutions. Remember in the beginning of the video, I mentioned that when you're solving rational equations, you can have 3 possible answers. You can have 1 solution, 2 solutions, or no solutions. And right now we have 2. But again, it's not guaranteed that these are the right solutions. So you have to go back and check your answers. So that does make the problem longer. but I'm sorry, it's just something you have to do. So 0 and negative 1 over 4 is what we're going to check. I'm going to start with 0 because that's probably the easiest number to use. Okay. There's 0, 0, 0, 0. Let me rewrite this. 5 divided by 0 cubed, which means 0 times 0 times 0 is 0. 0 squared is 0 times 0, which is 0. And then 0 times 5 is 0. 0 plus 0 is 0. 0 plus 5 is 5. 0 squared is 0 times 0, which is 0. When you are dividing by 0, meaning that the zeros are in the denominator, these are actually undefined. You actually cannot divide those. So then that means there's this equation doesn't work. So everything is undefined. Doesn't work, doesn't work, doesn't work. Okay? So what does that mean to our solution? So we checked n equals 0. So this solution that we had gotten when we solved, this is our extraneous solution. So how I like to remember extraneous solution is I think of it as false answer. The reason I call it a false answer is that it was the answer that we got because we solved for it, right? We solved for it. But when we check our answer, it doesn't work. So that's how I like to think of it as a false answer. So this is our extraneous solution. So that means it's not right. It's incorrect. So this is not a correct solution. So I'm going to check the negative 1 over 4. So you're probably like, why? It's probably the answer. I'm probably sure it is, but you have to check your work. Alright, I'm going to plug in negative 1 over 4, and that's what we're going to check. Okay, ready? We're going to deal with fractions. Oh man, alright. Negative 1 over 4 cubed means we're going to multiply this to itself 3 times. Plus 5. Negative 1 over 4 squared means multiply this to itself twice. Okay. That one is okay. Negative 1 over 4 squared twice. Okay, let's go ahead and start simplifying. I'm going to tackle these and these separately because of the plus sign. Okay? When you multiply fractions, you just have to multiply straight across. So the numerator stays the same. So 5 divided by negative 1 times negative 1 is positive 1. Positive 1 times negative 1 is negative 1. 4 times 4 is 16. 16 times 4, 64. Plus sign. Don't forget that. Well, let me actually move this. Plus 5. So if you're not sure, just turn that into a fraction and multiply straight across. 5 times negative 5 is 5 times negative 1 is negative 5. Negative 5 times negative 1 is positive 5. 1 times 4 is 16. Okay. Okay. I'm just going to leave this alone for now. We'll deal with the addition and subtraction a bit. I'm just going to do all the multiplications. 1 divided by negative 1 over 4 times negative 4 is positive. Negative 1 times negative 1 is positive. 4 times 4 is 16. Okay. So from here, we have to apply the next rule, which is when we add or subtract fractions. When you add or subtract fractions, you have to have the same denominator. So here, if you notice, 64 and 16 are not the same. I actually cannot simplify this fraction any smaller. So what I have to do is manipulate this one, 5 over 16. If I multiply 16 by 4, I get 64. So that's what I'm going to do. Multiply both numerator and the denominator. And I'm also going to just do this one now. Turn this into a fraction so I can take a look. Alright, so I need it to be a 4 because I can't shrink a 4 to be a 1. So I'm going to multiply this by 4, multiply this by 4, and that one is good. Okay. 5 times 4 is 20, 16 times 4 is 64, equals 5 times 4 is 20, 1 times 4 is 4. Okay, let me go ahead and add them. When you have the same denominator, you just have to worry about the numerator. So negative 1 plus 20 is actually positive 19, and the denominator stays the same. So this is going to be 19 over 64. Negative 1 plus 20, that's positive 19. The denominator stays the same. So that's positive 19 divided by 4. Okay. The next rule is when you're dividing fractions. When you divide fractions, that is going to be the same as multiplying it. So leave the numerator alone. Multiply instead of divide. The reciprocal, which is just to flip the fraction over. Nothing happens to the sign. Numerator stays the same. Instead of dividing, I'm going to multiply the reciprocal of this fraction plus numerator stays the same. Instead of dividing, I'm going to multiply the reciprocal of the fraction. Again, when you multiply straight across. So if you're not sure, just go ahead and just put the 1 at the bottom. So we have 5 times 64 divided by 19. Okay. So that means it's going to be a fraction, and I don't want to use decimals. So I will go ahead and simplify that in a bit. So this is going to be 320 divided by 19. (320 divided by 19). 4 times 4 is 16. 1 times 19 is 19. So 16 over 19. 16 over 19. 1 times 16 is 16. 1 times 1 is 1. So 16 over 1. Okay, we're almost there. Okay, we're almost there. Now, take a look here. It's still asking us to add, but I can't add because the denominators are not the same. I know this is too much, but we're going to finish it. So I'm going to turn this 1 into 19 by multiplying it by 19, both numerator and denominator. 16 times 19 is 304. So this is 304 divided by 19. 304 divided by 19. All right. So now that the denominators are the same, I can go ahead and just add the numerators. 16 plus 304 is 320. Denominator stays the same. And now they check out. Congratulations. Good job, everybody. So what does that mean? We had forgotten what we were even doing. What that means is that this solution that we just checked is correct. So the solution to this problem is not n equals 0, right? That's extraneous. It's n equals negative 1 over 4. So we only have one solution. Thank you, everybody, for holding it up with me. I hope this was helpful and it wasn't confusing. Now, the part 2 of the video, I will go ahead and just solve some of the problems that are on the assignment for this week. So go ahead and check that out. All right, I'll talk to you guys later. Bye.